Welcome to this Earth Science 2 Learning Set 1 review. What Makes the Weather Change? That's the name of our book, and this is a review of Learning Set 1. This is the first 4 lessons from the book. And what I've done is I've broken the review into 3 smaller pieces. So that's why it says Part 1. And on your success criteria sheet, we're going to be trying to do numbers 1, 2, and 3 in this first review. So number 1 on your review sheet is be able to construct a model of how a storm is created in the atmosphere. And you should be able to include the following parts. Now, what I'm going to do for this is I'm going to go right off your review sheet and I'm going to go through each one of those and show you where it's in this model. So this is the model that you've seen in class. This is the model that we've put up in class. So the first thing you have to be able to do is show the Earth. And obviously the Earth is going to be right down here. And this model really didn't do a good job of showing you where it is. So if I come over here and we can write that in. So I can write Earth. Okay, so the Earth is on there. Another thing you have to do is you have to be able to have a source of heat and a source of cold. So here you can see it says this is a hotter spot, this is a colder spot. One of the common mistakes is people say, oh, the hot spot or the source of heat is the sun and the cold is the earth. No. What we're talking about is the unequal heating of the earth. So some parts of the earth get more sunlight, they're going to be hotter, they're going to be warmer. And other spots are going to get a little bit less. This is going to be your colder spots. So have a heat and a cold source. Now the air molecules and the air masses. And this was identified with this key right here. So all these little dots here that you see are your air molecules. So I have them in there. Now why are some of them spread out and one of them close together? Well, what I'm going to be looking for is in the colder area, where it says colder, are these packed together more so than in your warmer area? And we've learned about cold heat, things that are hotter, things that have more energy like liquids versus solids, where in solids they have less energy, the molecules are more closely packed together. It's the same thing here. So these molecules should be spread out a little bit more where it's warmer, and where they're more packed together they should be colder. Now, how the air molecules and the air masses move. Well, obviously if it's the low area, this is going to be moving up and these are going to be moving down. So you technically, well, not technically, but you tend to have the warmer area rising up. And we know that warm air rises when you put your hand over the candle in the class, or if you have your hands high above the Bunsen burners, you'll feel the heat rising. Now, the next thing that I'm going to talk about is how the whole air masses move. Well, if this air is rising and over here it's sinking, that's where you're going to get your wind. So what's going to happen is the air rises, you're going to have wind coming in and it's going to be taking its place. So that's why I have the wind here. So you want to label that wind. You want to have that arrow in there. Now, areas of high and low pressure, well, anytime you have lifting happening, you're going to have lows. Anytime you have sinking of the air, you're going to have highs. Now, technically, that's not always correct. You tend to have highs when the millibars are over 1013, and you tend to have lows if they're below that. But for our purposes, where the air is sinking, we're going to have highs. Where the air is lifting, we're going to have lows. Now, it says clouds, and it says condensation and precipitation on your sheet. So all these go together. So the clouds are going to form on the sides where you have lift. And so don't have them on the wrong side, because if the air is coming down, you're not going to get condensation. So when that air rises, it starts to cool off, and then that water vapor changes into from a vapor to a liquid, and that's where you get condensation occurring. So you'd have your clouds, you'd have your condensation, and so make sure you talk about that. Make sure you label that. So what I might want to do is I might want to label this cloud. And then I might want to label this condensation inside here. And then even this, you may draw it, but do I know what you're talking about? So maybe you would label this rain. And then inside here, you would label this condensation. And by doing that, I know exactly what you're talking about, and there's no confusion there. So where's precipitation happening? Well, that's your rain. That's falling below the cloud. Don't have the precipitation over here where there are no clouds. Now, your front is right here. This is where you separate the cold area from the warm area. And this would go in as a diagonal, because as this comes in, it's actually going to be forcing the warm air up and over because it's less dense. And that's where you're going to have lift. Lift is one of the other key things that you have to have. So it's not necessarily this where the warm air is rising. The lift has to be on this front right here. And it's pushing it up like this. You could even have your arrow going like this, where the warm air is being lifted up and over. And a lot of times this is where you're going to get your clouds forming as well. So we've gone through all the different parts that you have to have on your, I'm just checking over the list, I think we've gone through over all the parts that you have to have on your store model. Make sure you put them in a correct spot. The number one mistake that I see is people will have these, but they'll have them in the wrong spots, and then they won't get credit for it. Now, one of the next questions you have to be able to answer is be able to describe where energy is being transferred or converted within your model. And there's lots of spots where that could be happening. So if I go back here, you can see that heat is conducted from the ground to the atmosphere. So you can label that. Well, you won't label that on your model. You have to be able to describe where it's happening. Heat is convected within the atmosphere. So convection is happening once through conduction, that you have the lower atmosphere heating up. Now the air is rising. Energy transfer during evaporation, so the water is evaporating. Then it's during condensation. Then during precipitation. Those are all places where energy is being converted from one form to another or being transferred in our model. Maybe you would talk about how solar energy coming down to the earth and heating the earth. Those are all different ways that you could talk about how energy is being transferred or converted within the atmosphere. And then finally, for this first review, be able to explain how wind is created. So remember, going back to your model, let's go to this one right here. So here's our model. As the warm, less dense air rises, the colder, more dense air comes in and takes its place. So as this air comes up and rises, you have the colder air coming in and replacing it. And this movement of air is called wind. It is primarily caused because of the unequal heating of the earth. And the unequal heating of the earth is what drives a lot, or most of our weather, in fact. So this does conclude the first part of our review. So make sure you look these over. Make sure you ask questions if you have them from Mr. Phillips or myself before the test, so you can do well on this part of the test. Thank you.